Now let us talk about fuel energy. That is the energy which is encased in fuels, various types of fuels. So by fuels we mean fossil fuels, and this energy that is contained inside these fuels is obtained or harvested by burning these fuels or treating these fossil fuels. Like you can perform any chemical reaction which can be burning of these fossil fuels, or they can be treated to produce to convert that energy into electricity. So or any other form of of energy. So fossil fuels are normally they come in many forms. They can be solid, which is like coal is a solid fossil fuel. They can be liquid, which is natural oil, that is a liquid fossil fuel. And then they can be in gaseous state, that is natural gas. We can also use natural gas to produce any form of energy. The heat energy in fuels is converted to mechanical energy by steam turbines or engines. IC engines, which are IC is short for internal combustion engines, which you find inside your cars, or gas turbines. And these turbines can convert the energy, the heat energy which is inside these fuels, into mechanical energy. By mechanical energy, I mean that the shaft of these turbines rotate. These shafts are then coupled to generators which rotate to produce electricity. So mechanical energy is converted to electricity via alternators, which are most commonly synchronous generators. Chief sources of electricity production. This means that this line means that the fossil fuels, even today, majority of electricity is produced by using fossil fuels. Although their resources are declining. Number one, they have declining resources. These fossil fuels are available inside the earth, and they take millions and billions of years to form. So once you use that fuel, you are not going to be replenishing that fuel in your lifetime, or in many lifetimes, in countless billions of lifetimes. So what we are doing right now is that we are utilizing these fuels, and they are depleting. Their declining resource is a problem, although they are chiefly used to produce electricity. So the trend nowadays is to reduce dependency on these types of fuels. The trend is to stop the use or reduce the use of these fuels to produce electricity, because they damage the environment so much. A lot of combustion is involved here, and a lot of environmental pollution is involved here. So the present trend is to just forgo these fuel resources in favor of alternative solutions which are environmentally friendly and sustainable. So um, this table compares various types of energy sources, and over here we can see that the comparison is made between water power or hydroelectric power, the power which is produced by fossil fuels, and the power which is produced by nuclear energy. So the parameters for comparison is: number one, initial cost. So initial cost of water power is very high, as we discussed earlier, that a lot of civil work is involved here. The initial cost for deployment of fuel-based power plants is very low, because the components are they have been in use for a lot of time, and their components have already been pre-designed. And if you want to install any fossil fuel power plant, you just have to go to the market and select the desired components, and then just assemble them. So the initial cost is very low for fossil fuel power plants. Nuclear energy has the highest cost yet, because obviously you have to build the structure of the plant so that radiation can be contained. Then running cost of the plant for water power or hydroelectric power is very low. It's very low because water is a free source of energy. It is free. It is free to use. So you can generate electricity from water, and running cost will be very low. The fuels which fossil fuels, their running cost is high, because the cost of acquisition of coal, oil, or gas is high. And then nuclear energy, it is written here that it has the least running costs. I would beg to differ from that, but it might be true. But I think it is a very close competition between nuclear energy and water power, because both are very cheap forms of energy. Then reserves. As far as reserves are concerned, Water reserves are permanent. Water is available and it will remain available as long as humankind exists, because if there is no water, humankind will cease to exist. So water resource is permanent. There is no problem here. The fossil fuels are exhaustible. Exhaustible, by exhaustible we mean that their resources are depleting, and they may deplete in 100 or 200 years, completely deplete in 100 or 200 years if no extensive resources are found in near future. So they are exhaustible. And then we use the term inexhaustible for nuclear energy, and inexhaustible is between exhaustible and permanent. So nuclear energy inside the earth's surface, only in Russia it was estimated that enough nuclear fuel is available in Russia to produce electricity for entire uh, of the country for thousands of years. So by inexhaustible, we mean that it is not permanent, but it is so readily available, and so much of it is available that we can, for the purpose of our conversation, we can say that it will not run out. So then we come to the parameter of cleanliness. So if we talk about cleanliness, the water power is the cleanest form of energy. Fossil fuels are the dirtiest form of energy because they produce a lot of pollution. Nuclear energy is clean, but because of nuclear waste disposal, it is not the cleanest form of energy. If we talk about simplicity, then water power, the construction of hydroelectric power plant is the simplest. Then the fossil fuel power plants, their construction is a bit complex because you have to involve a variety of systems, environmental protection systems and other systems, and you have to link them all together. So the fossil fuel power plants, they have complex constructions. Hydroelectric power plant has the simplest construction. You just need a dam, you need a gate, and then you need a passageway for the water. And at the end of that passageway, you install a hydroelectric turbine and generator, and that is it. So nuclear energy is most complex form of energy, and its construction is most complex. So its simplicity is the least. So if we talk about reliability, water power is most reliable, and nuclear energy is still reliable, but it is not as reliable as water power. But the least reliable of all of these energy forms is fossil fuels, and that has something to do with their exhaustible nature as well. And the other point is that fossil fuels need huge supply chains. Fossil fuel, to ensure that you have fossil fuel in your plant, you have to have a huge logistics infrastructure and huge supply chain. And if anywhere there is a slight hiccup, or due to any reasons, if the continuity of supply is affected, then these fossil fuel power plants cannot produce electricity, so they are least reliable. Now let us talk about energy units. So there are various forms of energy, and various units are affiliated with those forms of energy. For example, we have heat energy, and for heat, to measure heat energy, we normally use units like calorie or British thermal unit or centigrade heat unit, or in most of the cases kilocalories, which is just 1000 calories. And then we have mechanical energy, and that is measured in Newton meter or joules. And finally, we have electrical energy, which is normally measured in watt seconds or joule, or they can be measured in watt hours or kilowatt hours. Chiefly they are measured in kilowatt hours. But they can also be measured in joules, which is just watt into second, or watt hours, which is watt into hour. So it is very simple to make a relation between them. So 1 watt hour is equal to 1 watt into 1 hour. If 1 watt of power is delivered to a load for 1 hour, then the total amount of energy which is delivered to the load is 1 watt hour. So 1 watt into 1 hour gives you 1 watt into 3600 seconds, and that gives you 3600 watt seconds or 3600 joules. So if you want to find out what is the relation between joules and 1 kilowatt hour, 1 kilo is just the a watt hour has if 1 kilowatt hour has 1000 watt hours. So you can simply multiply this derivation with 1000 to get 36 into 10 power 5 joules, or you can also verify it by using by performing derivation as such. Let us try to explain the definition of some of the units of heat energy. So first of all, we define the calorie, which is the unit of heat energy. So calorie represents the amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. So if you have 1 gram of water and you raise the temperature of that water by 1 degree Celsius, then the amount of heat you used to do that is called 1 calorie. Then we have kilocalorie, that simply represents the amount of heat required to raise the temperature of 1 kilogram of water through 1 degree Celsius. So in the kilocalorie we had gram, and in the kilocalorie we have kilogram. So if you have 1 kilogram of water and you raise the temperature of that 1 kilogram of water to 1 degree Celsius, then you have consumed 1 kilocal energy to raise 1 kilocal of heat energy to raise the temperature of water 1 kilogram of water to 1 degree Celsius. So you can also convert between kilocal and cal very easily. So 1 kilogram into 1 degree Celsius is equal to 1000 grams into 1 degree Celsius, and as we know that 1 gram into 1 degree Celsius is already calorie. So there are 1000 calories in 1 kilocal. Then we come to British thermal unit. So this is the thermal unit which is utilized in UK, and all of the it is also adopted as the base unit to represent a lot of to represent the universal um, uh, universally represent the heat related quantities. So normally it is used, although it is not an SI unit or a standard unit, it is still utilized by the oil companies to represent the amount of oil they are trading. So British thermal unit represents the amount of heat required to raise the temperature of 1 pound of water through 1 degree Fahrenheit. So these are both CGS system units. So if you represent the amount of heat um, that is required to raise the temperature of 1 pound of water through 1 Fahrenheit, 1 degree Fahrenheit, then that is equivalent to 1 BTU. So centigrade heat unit is also another unit, but it is very rarely used, but still it is a unit, we have to define it. It represents the amount of heat required to raise the temperature of 1 pound of water to 1 degree Celsius. So now in British thermal unit you consider 1 degree Fahrenheit, but in Celsius, in centigrade heat unit you raise the temperature by 1 degree Celsius. So this is the only difference between these two units. Now let us talk about relationship between different units. So as we have already derived that 1 kilowatt hour is equal to 36 into 10 power 5 joules. So and we also know from experiments that 1 calorie is equivalent to 4.18 joules of energy. So 1 centigrade heat unit is the amount of heat which is required to raise the temperature of 1 pound of water through 1 degree Celsius. So 1 pound into 1 degree Celsius. So that gives you 453.6 grams, because in 1 pound there are 453.6 grams. So into 1 degree Celsius. So 453.6 into 1 gram into 1 degree Celsius, and this is right here is the calorie. So in 1 CHU there are 453.6 calories, or in terms of joules you can multiply these calories with the joule equivalent, and that is 4.18. You can multiply these calories by 4.18 and you can convert these calories into joules. So there are 1896 joules in 1 CHU. 1 BTU is in the similar in some manner it is proven that it is equivalent to 1053 joules, but this definition can vary. So 1 BTU is normally considered to be equivalent to 1053 joules. I am not including the derivation of this relation here, because in your books it is not proven right, and so we are going to leave this to your cells, and you can consult the internet for proper derivation of this quantity. But as far as our course is concerned, this is not that important. So next we can say that we can define another unit, that is 1 quad, and 1 quad is equivalent to 10 raised to the power 15 BTU of energy, 10 raised to the power 15 BTU of energy. And this unit is utilized when giving world energy production and consumption statistics. When we are giving the information about how much energy has the overall world consumed in a particular time period, and how much it has been produced, then we use this unit, which is 10 to the power 15 BTU, which is a quad. You will normally find this unit in world energy statistics. Then 1 kilowatt hour, as you all know, it is equal to 36 into 10 to the power 5 joules. So if we convert it into calories, then it is equal to 860 into 10 to the power 3 calories, or 860 kilocalories. And if we want to establish a relationship between kilowatt hour and CHU, then 1 kilowatt hour is equal to 36 into 10 to the power 5 joules. And since 1 CHU is equal to 1896 joules, so we divide it by 1896, we get 1898 CHU. So 1898 CHUs are inside 1 kilowatt hour of energy. Similarly, 1 kilowatt hour is also equivalent to 3418 BTU. You can simply divide 36 into 10 to the power 5 with 1053, and you will arrive at this figure. So 1 kilowatt is also equivalent to 3418 BTU of energy.